To say space is harsh is, well, an understatement. It's filled with creepy things. What about gamma ray bursts that could cancel your existence, and mine too, on our planet tomorrow? Or mysterious, eerie, empty supervoids that are up to no good either? Which one scares you the most? Well, let's watch and pick, huh? And the first scary thing on our list is space junk. Look up there at the night sky. You might think you see stars and a few satellites, but there's something else up there, a mess of space junk, and it's growing. Earth's orbit is our highest trash dump. Old satellites that don't work anymore, empty rocket parts, and thousands of broken pieces are all flying around the planet. And they're moving insanely fast, so fast that even a tiny fragment can hit with the force of an explosion. Right now, we're tracking over 30,000 objects in orbit, and that's just the big stuff. There are millions more pieces too small to see, but still dangerous. In space, even something the size of a marble can cause serious damage. Still, extreme planets are even spookier. In our own neighborhood, some planets are kind of overwhelming. Mercury can reach about 800 degrees Fahrenheit. Venus is even hotter at 860 degrees, thanks to its thick, heat-trapping atmosphere. For reference, the Sun's surface is around 10,000 degrees Fahrenheit. But that's nothing compared to Kelt 9b, the hottest planet ever found. Its temperature soars to roughly 7,800 degrees. That's hot enough to rip atoms apart. Under conditions like that, Mercury would vaporize into glowing plasma. At the opposite end is a planet nicknamed Hoth. It's about 5.5 times Earth's mass and sits at around minus 370 degrees, just barely above absolute zero. Even though it orbits a star, that star is a dim red dwarf, so the planet gets almost no heat. Size-wise, Jupiter dominates our solar system. This gas giant outweighs all the other planets combined. But this planet, I'll let you read its name, is on another level. It's about 28 times Jupiter's mass, a big boy. It's so huge that scientists think it might actually be a brown dwarf, a failed star that almost ignited nuclear fusion. And then there's Venus, our solar system's climate nightmare. It's similar in size to Earth, but wrapped in crushing air that's nearly 1,000 times denser than ours. Winds there race at over 220 miles per hour. Sulfuric acid rains from the clouds, and the surface pressure would flatten you instantly. Sounds terrifying, but only until you hear about supernovae. A supernova is the most powerful explosion we've ever witnessed. It's what happens when a star ends its life in a massive, blinding blast that can briefly outshine an entire galaxy. So, what causes it? One type of supernova happens when a very large star, at least 5 times heavier than our Sun, runs out of fuel. While it's alive, the star stays stable because two forces are fighting against each other: gravity pulling inward and energy from nuclear reactions pushing outward. But once the fuel is gone, that outward pressure disappears. Gravity instantly takes over, and the star collapses in on itself in seconds. The collapse creates huge shock waves that blast the outer layers of the star into space. It's rather intense. But not as intense as colliding galaxies. You see, galaxies are bound by gravity and are constantly moving. That's why collisions are common, especially between large galaxies and their smaller companions. When a small galaxy drifts too close, the larger one's gravity ruthlessly pulls it apart, robbing it of its stars and gas and absorbing them completely. When galaxies of similar size collide, the outcome is even more destructive. Their spiral structures are torn apart, and neither galaxy keeps its original shape. Well, this sounds impressive, even by universal standards. And still, gamma-ray bursts are even more menacing. Those are the most powerful explosions in the universe. In just a fraction of a second, a menacing star many times heavier than our Sun collapses into a black hole. As it does, the star's outer layers are ripped away, and two narrow beams of energy blast out in opposite directions. These beams are so bright, we can detect them from billions of light-years away. In that minuscule instant, a gamma-ray burst releases more energy than the Sun will produce over its entire lifetime. It's not just a supernova, it's a supernova. Now, gamma-ray bursts are rare, but they're incredibly dangerous. Astronomers estimate their destructive effects could stretch across thousands of light-years. If one were to occur within about 5,000 to 8,000 light-years of Earth, the consequences would be catastrophic. One side of the planet would get flooded with deadly radiation. The ozone layer would be badly damaged or completely destroyed, leaving life exposed to intense radiation from space. The result would be a mass extinction, on the same scale as the asteroid that wiped out the dinosaurs. Now we're approaching something even scarier, something most of us are too afraid to imagine. I mean, other civilizations. What if they find us? There's something called the dark forest idea. Imagine the universe as a pitch-black forest. Everyone's hiding. If one civilization makes noise, another, far more advanced, might wipe it out instantly, not out of cruelty, but out of fear. In a place this big, staying silent might be the safest move. Another alarming idea: what if a super-advanced society wouldn't even see us as people? We'd be more like trees in a forest or fish in the ocean. Planets could just be raw materials, and life could be perceived as just a byproduct. There might even be civilizations so advanced they could use the energy of an entire star or even a whole galaxy. At that level, erasing a planet like Earth wouldn't take effort. Thinking about it is a little unsettling. Even more unsettling is considering the existence of supervoids. Those are some of the most mind-boggling structures in the universe. Imagine a patch of space so empty it's missing roughly 10,000 galaxies. It's cold, vast, and almost completely devoid of matter. A supervoid doesn't fit into our current models of the cosmos, and scientists often describe it with the word unthinkable. But it's not completely nothing. A few lonely galaxies drift inside, which is somehow even more sinister than total emptiness. The edges of the void aren't smooth. They have temperature shifts and subtle changes that hint at some invisible forces. Even light seems to get distorted there, making these regions super eerie. But the worst part is that some supervoids can impact us. For example, something strange is moving our galaxy through space at about 1.2 million miles per hour. In front of us, a massive cluster of galaxies, called the Shapley concentration, 650 million light-years away, is pulling us toward it. And behind us, scientists discovered a nearly empty region of space with almost no galaxies. They call this supervoid the dipole repeller, and it's shoving the Milky Way with incredible force. But it's probably better than being propelled toward a black hole. Black holes are some of the universe's most ruthless objects. They can swallow asteroids, comets, planets, and even stars. Almost every black hole starts its life as a massive star. Then it runs out of fuel, it collapses in on itself, and packs more mass into a tiny space than you can imagine. That's why its gravity is so insane even light can't escape. A lot of people picture black holes as giant cosmic vacuums, pulling up everything around them. But that's a myth. Black holes can only pull in stuff that gets super close, crossing what's called the event horizon, a point of no return. For a black hole with the mass of our Sun, that boundary is just about 2 miles across. And for a black hole as small as Earth, the event horizon would be just a couple of inches wide. Still, their gravity is powerful enough to influence stars and planets nearby. And now, we're finally ready to speak about the ultimate nightmare the human brain simply can't comprehend: the sheer size of the universe. Imagine this. You're sitting in your room. That room is inside your house. Your house is on Earth. Earth is part of our solar system, which has 8 planets. And that solar system is just one tiny neighborhood inside the Milky Way galaxy, home to at least 100 billion other planets. Now, it is getting wilder. The Milky Way is just one galaxy in a local group with few others. That group sits inside the Virgo supercluster, which contains hundreds of galaxies. And all of that is just a small part of the observable universe, which stretches about 93 billion light-years across. And that's only what we can see with our current tech. We have no idea how much bigger the universe actually is, or if it even has an end. Think about that. Well, I hate to break it to you, but I'm told that our Earth might not be so special after all. Scientists say it could just be the last planet in our solar system that hasn't moved on yet. Yep, the worrying part is that it looks like planets don't stay Earth-like forever. They pass through it. Atmosphere, liquid water, internal heat, magnetic shields – all that lines up for a while, and then, slowly, it unravels. Now, for a long time, scientists treated Earth-like planets as cosmic unicorns, 1 in 100 star kind of rare. But when they ran updated models with better physics and geology, researchers realized that if the conditions line up, Earth-like planets with liquid water could exist around almost every star. Not 1 in 100, potentially 1 per star. That's 100 times more common than they thought. Our Milky Way alone has at least 100 billion stars. Hey, suddenly the universe doesn't feel empty at all, and planets don't even need oceans splashing on the surface to count. Many worlds that look frozen on the outside could be hiding liquid water deep below their crusts, quietly warm and stable. It's already happening in our own backyard. Moons like Europa and Ganymede around Jupiter and Enceladus around Saturn look like icy balls from space, but underneath their cracked shells there are global saltwater oceans. Even dwarf planets like Pluto and Ceres show signs of buried water. The secret sauce is heat. Radioactive elements inside a planet slowly release energy, like a tiny heater that never shuts off. Plus, gravity from nearby giant planets stretches and squeezes these worlds and creates friction heat. So, it seems pretty easy for Earth-like planets to form. And if you look at modern planet formation models, you'll see rocky planets like ours pop up all the time. It's possible that the early solar system didn't just make one Earth. It made several attempts. Mercury, Venus, Earth, and Mars all form from the same neighborhood, same materials, same chaos. Exploding stars nearby, called supernovae, sprayed heavy elements like iron and nickel into the cloud that became our planets. That gave them solid cores, internal heat, and the potential for magnetic fields. That's the starter kit for an Earth-like world. So instead of Earth being a miracle, it starts to look like the survivor of a group project where everyone else dropped out. Now, Mars is the first planet in this dropout group that has been actively giving away clues that it wasn't always the dry, rusty place we see today. Scientists have spotted river deltas, minerals that only form in water, and landscapes that look carved rather than blasted. All signs point to the same thing: Mars used to be wet. The big question was never if there was water, but what kind of world it created. Was Mars frozen with bursts of melting ice, or was it warm enough to hold long-lasting oceans? New evidence tips the scale towards something huge. Around 3 billion years ago, Mars likely had a massive ocean covering most of its northern hemisphere. It was not a patchwork of lakes, but one connected body of water. That idea comes from studying the biggest canyon system in the solar system. It stretches about 2,500 miles long and up to 120 miles wide, dwarfing Earth's Grand Canyon by comparison. There is an area inside the canyon where signs point to a deep ancient lake. Scientists found special layered deposits along the canyon walls that show rivers once flowed into the canyon. Even stranger, all these deposits sit at almost exactly the same height. That tells us the water level stayed stable for a long time, and depths reached nearly 3,300 feet in some places. The canyon floor sits higher than Mars's northern lowlands. If water filled the canyon that deeply, it had to spill outward, flooding the entire northern half of the planet. In other words, Mars wasn't just wet, it was blue. This discovery comes with a warning. Mars shows how precious water really is and how easily a planet can lose it. It looks like Mars didn't fail because it was weird or flawed. Studies now show its core stayed hot and solid for a long time, very Earth-like in structure. The difference is in size. Mars is smaller, so it cooled faster. Once the core slowed, the magnetic field weakened. Once the field weakened, the atmosphere started leaking into space. It's like trying to hold water in a bucket full of tiny holes. Eventually, gravity loses the fight. Alright, and what about Venus and its potential for life? It has always looked like Earth's evil twin – poisonous air, crushing pressure, surface hot enough to melt lead. But NASA's Magellan mission back in the early 1990s collected some data that tells a completely different story, one where Venus might still be alive on the inside. Magellan arrived at Venus and did something no spacecraft had done before. It mapped the entire planet's surface and gravity field in detail. At the time, scientists mostly used the images to catalog craters and strange landforms. But now, with better models and computing power, researchers are rereading that data and realizing Venus may be far more geologically active than anyone assumed. The biggest clue comes from massive features called coronae. These are large, almost circular formations that can stretch dozens to hundreds of miles across. It's like a giant blister in the planet's crust. Venus doesn't have moving tectonic plates like Earth, but that doesn't mean nothing moves. Hot, buoyant material from deep inside the planet, the mantle, can push upward, warping and cracking the surface from below. When they combined Magellan's gravity data with its topography maps, scientists managed to peek beneath Venus's crust. They noticed hidden mantle plumes, rising columns of hot rock that don't always show up in surface images alone. Around some coronae, researchers even found signs of subduction, where one section of crust sinks beneath another. Plus, something called lithospheric dripping, where dense surface material slowly sinks back into the mantle like cooling wax. Now all this sounds cool, but it starts feeling way more personal when you find out Earth may have looked like this once. Coronae don't exist on modern Earth, but they might have formed billions of years ago, before plate tectonics fully took over. Studying Venus today could be like looking at a snapshot of Earth's deep past. And this is just the warm-up. NASA's Veritas mission will return to Venus with modern radar, build 3D global maps, analyze surface chemistry, and measure the planet's gravity field in far greater detail, up to 4 times sharper than Magellan. If Venus is still shifting, dripping, and churning inside, Veritas will catch it in the act. Now, Venus isn't the only planet getting a second look thanks to dusty old data files. Back in 1986, Voyager 2 flew past Uranus and sent back a snapshot that confused everyone. Uranus looked like a cold, tilted, icy giant wrapped in one of the strangest magnetic bubbles ever seen. Its magnetosphere, the invisible magnetic shield around the planet, made no sense. It was tilted by about 59 degrees, shoved off-center inside the planet, and paired with a planet already lying on its side at a 98-degree tilt. Even weirder, Voyager 2 found that Uranus's magnetosphere was almost empty. Very little plasma hung around inside it. Instead, scientists saw dense belts of high-energy electrons, packed way tighter than expected. For decades, researchers assumed this was just how Uranus worked, a permanently broken magnetic system. But now, they reanalyzed Voyager 2's data with modern tools and decades of new knowledge about space weather. And it looks like Voyager 2 didn't catch Uranus in its normal state at all. It caught it when a solar storm was passing Uranus. So Uranus might not be permanently weird. And since our entire understanding of Uranus is based on a single flyby during a cosmic storm, it could be hiding plenty of secrets. Put all this together, and the solar system starts to look less like a tidy family and more like a graveyard of transformed former Earths. And when scientists say Earth isn't a planet type, but a phase, they're not just being dramatic. Earth just happens to be the last one in the solar system still holding the line. You know, we've all begged for just 1 extra hour in the day. Actually, 2 hours would be better. Well, scientists have good news and bad news. The good news is that our planet is heading toward a future where a day could last 25 hours. The bad news is that eventually, the same physics that makes the day longer will also get rid of our planet's rotation, literally freezing Earth in time. Meaning endless days and nights and oceans fleeing to the poles, all while the atmosphere turns into a relentless planet-wide storm. Uh-oh. Now, back when the Earth was just a massive, messy cloud of dust and gas, gravity started pulling everything toward the center. As all that debris smashed together, it started to swirl, like water rushing down a drain, but on a cosmic scale. That spin caused a momentum. Since space is a vacuum, there was no air to slow us down. Earth just kept spinning, and that spin became a day. One full rotation takes about 24 hours, and that's the rhythm we've known since we started recording time. But the thing is, we adopted 24 hours as a close estimate. In truth, a day is never exactly 24 hours long. Now, basically, Earth keeps spinning, but it's constantly losing tiny bits of speed. That's mostly because mass keeps moving around. Think of it like a figure skater. If they pull their arms in, they speed up. If they put them out, they slow down. Earth does the same thing, except without arms. When the 2011 earthquake hit Japan, it shifted the ocean floor so violently that it pulled Earth's mass inward, instantly shorting our day by 1.8 microseconds. Conversely, as glaciers melt and water rushes from the poles to the equator, Earth's arms are spreading out, causing us to drag. We're not just sitting on a big rock. It's like we're on a wobbly spinning top that moves every time something heavy happens on it. Most days end up being a few milliseconds longer than 24 hours. We can't feel this, but atomic clocks can measure it. Over long periods of time, those milliseconds add up. And as they do, the length of a day slowly increases. That's how a 24-hour day starts drifting toward 25. To check this, scientists pulled together nearly 3,000 years of sky records. Thousands of years ago, people carefully recorded eclipses. It was a scary event. Kings, priests, and astronomers wrote the exact time and location when the sun vanished. Those records survived on clay tablets, scrolls, and manuscripts. For the sky to go dark, the sun, earth, and moon must line up perfectly. If the timing is off by even a second, the shadow falls on the wrong part of the world. Today, astronomers know the moon's movements with incredible precision. They actually bounce lasers off mirrors left on the lunar surface to measure its orbit. That's why, in theory, we should be able to rewind the past like in a YouTube video and see every ancient eclipse exactly where history records it. But when scientists tried that, the moon showed up too early, or too late. The shadow wasn't where the record said it should be. The puzzle only solves itself when you realize one thing: Earth used to be a little faster. When researchers adjust Earth's rotation to be slightly quicker, everything snaps into place. In other words, Earth was spinning a little faster in the past, and these eclipse records show it. On average, this translates to a day increasing by about 1 to 2 milliseconds every 100 years. That's a thousandth of a second. You'll never notice it. But over time, those tiny bits stack up. About a second every 10,000 years. That means we're roughly only 200 million years away from having that one additional hour of sleep. So the good news turns out to be only meaningful for future Earthlings. But why is this actually happening? Well, the answer is the moon. Its gravity grabs Earth's oceans and stretches them into huge tidal bulges. But because Earth spins much faster than the moon moves around us, those bulges don't sit neatly under the moon. They get dragged slightly ahead as the planet rotates. That means the oceans are constantly being dragged across the planet, rubbing against the seafloor and the continents. That rubbing creates friction, and friction is a thief. Where there's friction, there's heat. So the moon slowly turns Earth's spin into heat that spreads through the oceans and into space. And once that energy is gone, it's gone for good. Since there's no visible cosmic creature to push Earth back up to speed, day after day, the moon acts like a slow, steady brake, stretching our days little by little and drifting farther away as it does. Yes, as much as we used to fear that the moon would collide with Earth one day, it's actually going in the opposite direction. All that transfer of energy that's happening between Earth and the moon is slowly pushing our satellite further away, approximately 1.5 inches per year. We know this because during the Apollo missions, astronauts left mirrors on the moon's surface, and today scientists fire lasers at those mirrors and time how long it takes the light to come back. However, even though we are slowly pushing the moon away, don't panic. It's not packing its bags just yet. At the current rate, it would take tens of billions of years for the moon to retreat significantly. But it will stick around long enough to witness and maybe even cause the end of all ends, so to speak. The same braking force that is slowing us down now could eventually push Earth into a state called tidal locking. This has actually already happened to the moon. You know how we never see the dark side of the moon from Earth? Well, that's because Earth's gravity grabbed the moon eons ago and forced its rotation to stop relative to us. Well, if you give it enough time, the universe could return the favor. If Earth slows down enough to match its orbit around the Sun, the cycle of day and night will disappear. We could turn into what astronomers call an eyeball planet. Because the Sun would just hang motionless in the sky, the side facing it would turn into a blistering scorched desert. That's the pupil of the eye. The side facing away would freeze into a massive white shell of ice, the white of the eye. The only spot where life could hang on in this area is called the iris, a narrow strip caught between the crazy hot day and the frozen night. But even that wouldn't be a dream come true. You'd have super hot air on one side smashing into freezing air on the other. So this zone would be hit by insane hurricane-level winds whipping across the surface. Also, without Earth's spin shaping the oceans, water would slowly migrate away from the hot regions and collect in colder zones, reshaping coastlines and continents entirely. The planet wouldn't just have longer days. It wouldn't even look like Earth anymore. But here is the bright side. We will actually never see this happen. And neither will our descendants, at least not while watching from nearby. The math says it would take about 50 billion years for Earth to stop spinning and turn into that frozen eyeball fully. But our Sun doesn't have that kind of time. In about 5 billion years, the Sun will run out of fuel. It will expand into a red giant, swallowing the inner planets and likely vaporizing Earth entirely. Bye-bye! So, while Earth is slowing down, it will never actually get to zero. We won't end as a frozen, motionless rock. We'll end as we started, space dust. By the time Earth ever stops spinning, humans certainly won't be watching from the solar system. We might be scattered across the galaxy, living in space, or not even human anymore. Some of us could live inside massive structures built around stars, capturing their energy instead of orbiting them. Others might drift near black holes, using their gravity and energy in ways we barely understand today. Entire civilizations could exist as uploaded minds, connected through a galaxy-wide network, living in simulations instead of physical worlds. Well, wherever we are, Earth would just be an old planet concluding its story.
Last summer, astronomers noticed something off, and it was, wait, that's not supposed to happen off. They spotted a weird mix of signals in their data. After double-checking, triple-checking, and probably staring at the screen in silence for a while, they realized it was something they'd never seen before. They may have just caught the first ever super kilonova. You've probably heard of supernovae, those big dramatic explosions marking the end of a star's life. It happens like this. A massive star runs out of fuel, its core collapses, and it blows itself apart. Sometimes a white dwarf star steals too much material from a nearby companion using its super powerful gravity. That stolen gas, mostly hydrogen, spins around the white dwarf in a disk and then slowly falls onto its surface, eventually triggering a massive thermonuclear blast. By the way, since we've mentioned it, A white dwarf is the scorching hot, ultra-dense core that remains after a small or medium-sized star, like our Sun, exhausts its nuclear fuel and blows off its outer layers to form a planetary nebula. Then, over billions of years, it slowly cools and becomes a theoretical black dwarf. It's roughly the size of Earth but packs around the Sun's mass, which makes it incredibly dense. Black dwarfs are powered only by leftover heat, not ongoing fusion. Either way, the birth of a supernova is loud and bright. These explosions often leave behind a neutron star, which is so dense that a single teaspoon of it would weigh about 1 billion tons. Basically, less star and more cosmic anvil. But then there's this rarer kind of VIP event, the kilonova. Astronomers have only ever seen one of those. Back in 2017, one event confirmed what scientists had predicted for decades. 2 neutron stars slammed into each other and shook space-time with gravitational waves. Such collisions don't just look cool, they create heavy elements like gold and platinum. Kinda like a cosmic factory. There's a chance that the gold in your phone or on your finger was forged in a violent neutron star crash billions of years ago. Kilonovae have a signature look. The explosion produces so many heavy metals that they block blue light, leaving behind a deep red glow. It's subtle and incredibly hard to catch. Now, here's where things get interesting. What astronomers spotted in 2025 didn't really fit into the supernova box, but it didn't look like a regular kilonova either. It was too powerful and too strange. Neither did it behave the way either event should on its own. That's why some scientists believe they might have spotted something new, a super kilonova. We're talking about a collision or chain reaction so extreme that it goes beyond anything we've observed before. Right now, it's too early to draw conclusions. Astronomers are arguing politely, running more simulations, and waiting to see if the universe decides to do it again. Because in the universe, twice is often the proof. But how could this super kilonova occur? Scientists suggest quite a wild sequence of events. Picture this. A massive star collapses in a supernova, but instead of leaving behind one neutron star, it produces 2. Almost immediately, those 2 ultra-dense remnants begin spiraling toward each other. Within moments, they collide and merge, setting off a kilonova on top of the original explosion. In other words, it could be not just one cosmic blast, but a chain reaction. 2 of the most extreme events in the universe happening nearly back to back. The mystery itself started on August 18, 2025, when the LIGO and Virgo gravitational wave detectors picked up a signal from 1.3 billion light-years away. The event immediately caught attention. The ripples in space-time looked exactly like what astronomers would expect from 2 neutron stars crashing into each other. But there was a plot twist. The International LIGO Virgo Cagra team quickly alerted astronomers worldwide. The data suggested a neutron star merger, but at least one of the objects seemed unusually small. Together, the pair weighed just 0.87 times the mass of the Sun. But neutron stars aren't supposed to be that light. According to everything we know, they should weigh at least 1.2 solar masses. At the same time, the analysis showed a 99% chance that one of the neutron stars fell below that limit. That shouldn't happen under normal conditions. So either the models were missing something, or this object formed in a completely different way. For example, it could be some kind of exotic birth during the collapse of a rapidly spinning, neutron-rich star. So, just a few hours after the alert, the Zwicky Transient Facility at Palomar Observatory spotted something curious. There was a fast-fading red glow coming from the same patch of sky. At first, it seemed that this discovery could solve the puzzle. For the first 3 days, the object behaved exactly like a kilonova. It glowed deep red, which is a sign of freshly forged heavy elements like gold and platinum. Everything matched: the timing, the color, and the gravitational waves. Astronomers thought they were witnessing the second confirmed kilonova ever seen. And that's where things got weird. On day 4, instead of fading away like a kilonova should, the object started getting brighter and bluer. That's like a major red flag in astronomy. Follow-up observations from the Keck Observatory in Hawaii revealed signatures of hydrogen and helium in the light, and those chemical fingerprints do not belong to kilonovae. They belong to supernovae, more specifically, a Type 2b stripped envelope supernova. This kind of explosion happens when a massive star loses most, but not all, of its hydrogen before blowing itself apart. It often happens because a nearby companion star siphons material away. At that point, many astronomers wrote the event off as a normal supernova that just accidentally happened near the gravitational wave signal. After all, regular supernovae don't usually produce detectable gravitational waves, but the timing and the early kilonova-like behavior, plus the strange mass measurements, didn't fit into that explanation. The event started to look like something far stranger. Now, most researchers still admit there's a chance all of this was just bad cosmic timing. Statistically speaking, they can't fully rule out that the neutron-star merger and the explosion just happened to occur near each other by coincidence. Still, the overlap in both time and location looked strange, and they couldn't ignore it. What if both signals came from the same catastrophic event? It would be an extreme scenario involving a rapidly spinning massive star. This star wouldn't collapse into a single dense core. Instead, its breakneck spin would cause the core to split in two, forming a pair of tiny underweight neutron stars. These newborn neutron stars wouldn't last long. Almost right after birth, they would spiral toward each other and collide. That crash would send out gravitational waves and create heavy elements, just like a normal kilonova. But all of this would happen inside a much larger supernova explosion. In other words, it would be a hybrid. One cosmic disaster stacked on top of another. Interestingly, the term superkilonova wasn't actually invented for this discovery. Originally, it described a theoretical event where a massive, fast-spinning star collapses straight into a black hole, surrounded by a huge disk of material. This material is capable of producing giant amounts of heavy elements, possibly several times the mass of the Sun in gold and platinum. The new study suggests using superkilonova to describe a supernova that briefly creates and destroys a pair of neutron stars before anyone notices what really happened. The team is careful not to oversell the idea. After all, the event happened far away. Moreover, the signals overlap in complicated ways, and untangling them perfectly isn't possible with current data. So, coincidence is still on the table. But if superkilonovae turn out to be real, they would help us solve several mysteries at once. For example, they offer a way to form low-mass neutron stars and help explain how the universe's heaviest elements might be created. Future observatories could help us figure out this phenomenon. Upcoming missions like NASA's Nancy Grace Roman Space Telescope and the UVEX satellite will watch the sky, increasing the chances of catching more of these blended explosions. If astronomers start detecting more mergers involving unusually small neutron stars, the case will finally be solved. Until then, the idea of a supernova and a kilonova happening together remains one of the most intriguing what-ifs in modern astronomy.
Ooh, that quick flash. Did you see it? That's an object smashing into the moon at unbelievable speed. And what makes it so special is that we almost never catch lunar impacts in real time. We still don't know what exactly hit it, but scientists think it might be linked to the Phaethon asteroid, one of the strangest, most mysterious objects we know of. This impact happened on December 12, 2025. Andrew Marshall Lee, a final-year PhD student, was doing a late shift at the Armagh Observatory and Planetarium in Northern Ireland. He was working with the Armagh Robotic Telescope, the newest and most advanced one there. Everything seemed normal at first. The moon was just sitting quietly on his screen. But then, around 3 in the morning, something unexpected happened. He saw a flash. That was the impact of a small object hitting the moon. The team is still trying to pin down its exact size, but they think it was no bigger than 2 inches across, which is about the size of a golf ball. And this object was moving insanely fast, at about 22 miles per second. To give you an idea, it's more than 100 times faster than a commercial jet. And yeah, I get it. When you watch the video, it's only a quick blink. It's not exactly thrilling. But the fact that Marshall Lee caught the exact moment it happened is actually super rare, and that's what makes this one such a big deal. It's the first video recording of a lunar impact flash in Ireland, and only the second one ever recorded from the United Kingdom. But just because it's rare to see that kind of event happen, that doesn't mean impacts on the moon are rare. It's actually the total opposite. We have a huge advantage on Earth, our atmosphere. It works like an invisible shield. It slows down incoming space debris, and it can even burn a lot of it up before it reaches the ground. But the moon doesn't have that kind of protection. So our poor natural satellite gets hit all the time by asteroids and meteorites. The good news is, most of what hits it is tiny, no bigger than little specks of dust. Now, if we talk about slightly bigger ones, we can look at some rough numbers. Scientists think around 100 space rocks the size of ping pong balls hit the moon every single day. That adds up to roughly 36,000 in a year. So, it's kind of strange that we don't capture these impacts more often. But the explanation is actually pretty simple. As we mentioned earlier, these space rocks are usually tiny, and if a ping pong ball already looks small here on Earth, imagine something that size flying through the huge emptiness of space. We can say it's basically invisible. That's why we usually can't spot them with a telescope. They're too faint for that. But the moment one of these little objects hits the moon at a crazy high speed, everything changes. The energy from the impact turns into heat and light. It blasts and melts a bit of the surface, and for a split second, it makes a bright flash that we can see from Earth. And there's one more problem. The moon is huge. Impacts can happen anywhere on its surface, so it's almost impossible to keep a telescope pointed at the exact spot where the next big hit will happen. So, most of the time, scientists don't catch lunar impacts with their own eyes. What usually happens is that they record the moon for hours, run all that footage through some software, and the program flags it if a flash shows up. But in Marshall Lee's case, he just happened to be looking at the screen at exactly the right moment, and he saw it happen live. Now you get how lucky he was, right? For now, the team has a pretty good idea of the space rock's size and speed, but it's still hard to say exactly what it was or where it came from. Their best guess is that it was linked to the Geminid meteor shower, which happens in December. And that actually makes sense. Lunar impacts are more likely to be spotted during big meteor showers, when the moon passes through streams of leftover space debris. So this could be one of those moments where the timing was just perfect. Now, the Geminid meteor shower is tied to one of the strangest space objects we know of, called Phaethon. It's labeled an asteroid, but it certainly doesn't behave like a normal one. You see, when Phaethon gets close to the Sun, it brightens up and even forms a tail, just like a comet. But its tail isn't made of dusty material the way comet tails usually are. According to NASA, its tail is made of sodium gas. That's why scientists are not totally sure what to call it. So, for now, Phaethon is officially listed as an asteroid, but a very weird one. Anyway, this strange object swings closer to the Sun every December, and when the heat gets intense, Phaethon starts shedding tiny bits of rock. When those little pieces dive into Earth's atmosphere, they burn up and make bright streaks across the night sky. At the peak of the Geminid shower, people can spot up to 120 meteors an hour under perfect conditions. The Geminids are usually bright and fast, and they often look a bit yellow. Of course, not all of those pieces hit Earth. Some miss us completely, and a few end up hitting the moon instead. And that's probably what Marshall Lee saw that night. Now, even though the impact wasn't huge, Flashes like this are still really useful for science. Astronomers use them to estimate how often the moon gets hit by small space rocks. And once they know that, they can make better guesses about how many bigger asteroids are out there, the kind that could make it through Earth's atmosphere and cause real damage. And sightings like this matter for the future too, especially for space travel. Space agencies want to build bases on the moon, and the goal is to make it a place where people can stay and work, not just visit. The moon is our closest neighbor in space, so it's a great place to learn new things and try out new tools. It's also the perfect practice ground for bigger missions later on, like sending humans to Mars. NASA, for example, is working on something called Artemis Base Camp. The plan is a small base near the moon's south pole, with places for astronauts to live and work, plus a rover that can travel farther from where they land. NASA also has plans for the Lunar Gateway, a small space station that would orbit the moon and help crews and supplies move between Earth and the moon's surface. There's also the International Lunar Research Station program. Its goal is to build a long-term research base on the moon, starting with robotic missions that land first and prepare the area before people arrive. The program focuses on using local resources, such as ice in the moon's soil, to produce water, oxygen, and other supplies needed for life. By staying on the moon for longer periods, scientists hope to learn how humans can live and work far from Earth and use this experience to prepare for future missions to Mars and beyond. So, keeping an eye on these impacts and learning more about them could actually help us build a safer future beyond Earth. The more we understand how often these hits happen and how strong they are, the better we can plan and protect future lunar bases. In a way, that tiny flash on the moon isn't just a cool moment on a screen. It's a small warning and a useful lesson for what comes next. So, we just spotted an asteroid so massive it could wipe out an entire continent if it ever hit Earth. And it's moving insanely fast, almost record speed. But what makes it really scary is how it's basically playing hide and seek with us. It can slip right into the sun's glare and vanish completely. And yeah, it just did it again. It disappeared. So, when we finally spot it again, will we have enough time to prepare? Or could it already be too late for humanity? Do I have your attention now? Thanks. So, meet 2025 SC79. That's a mouthful, so I'll just nickname it Scooby. This newly found asteroid is a sneaky one, the kind that loves hiding in the sun's glare. Think of it as trying to spot a firefly next to a stadium light. The brightness hits your eyes and outshines anything faint nearby, so yeah, you won't see that firefly. Now, asteroids hide in the same frustrating way. When they end up close to the sun from our point of view on Earth, the glare overwhelms our telescopes, and the asteroid's dim, reflected light gets lost in it. That's why some asteroids can cruise along in the sun's direction and stay basically invisible to us. And scientists say the most dangerous asteroids, the ones that could wipe out a whole city, are the hardest to detect. That's why astronomers need to somehow dodge the sun's glare. One way they do it is by observing the sky during the short window of twilight. Right before sunrise or just after sunset. And that timing is a big deal, because it's the only way to catch some risky asteroid before it sneaks up on Earth. Scientists say that if one of these so-called twilight asteroids ever gets close to Earth, it could be a serious impact threat. And it was during one of these twilight observing sessions that scientists finally spotted this huge asteroid. It was September 27, 2025. Scott Shepard, an astronomer at a Washington-based institute, was scanning the sky, hunting for anything unusual in our solar system. And he had an incredible tool in his hands, the Dark Energy Camera, or DECAM, one of the most powerful sky survey cameras on Earth, built to spot faint objects across huge areas of the universe. At one point, he spotted a faint dot moving across the image. So he quickly aimed the high-tech camera at it, and things got more interesting. Its movement matched what astronomers expect from asteroids that orbit very close to the sun, Then, follow-up observations with the Gemini and Magellan telescopes confirm the discovery. Yes, this really was an asteroid, and there are two particularly curious things about it. First, it's fast, like really fast. In fact, it is the second fastest known asteroid orbit in the solar system. It loops around the Sun once every 128 days. For comparison, Mercury, the closest planet to the Sun, takes 88 days to go around once. Second, its orbit is super rare. This is only the second known object that stays completely inside Venus's orbit. That also puts it in one of the rarest asteroid groups out there, the Asteroids. These are asteroids whose orbits sit entirely inside Earth's orbit. Astronomers have found only a few of them so far, and Scooby is the 39th one in the list. The team of scientists also figured out that this asteroid is pretty big, measuring about 2,300 feet across. It's roughly the size of Merdeka 118, the second tallest building on Earth. If an asteroid this size ever slammed into Earth, it wouldn't just be bad, it would be catastrophic. We're talking about damage on a continental scale. It would blast a huge crater into the ground, then throw out a shockwave powerful enough to wipe out forests and wreck cities. Seismic waves would ripple through the crust, triggering widespread earthquakes around magnitude 7.4, and people could still feel them about 300 miles away from the strike. And that's not all. A brutal air pressure blast would race outward, shattering windows more than 1,000 miles away. Then comes the aftermath. Dust and debris from the impact could shoot up into the atmosphere, block some sunlight, and mess with our climate. I know, you might feel scared right now, but don't worry about it. Thankfully, Scooby isn't going to do anything like that, because it's not on a collision course with Earth. Right now, the math shows it won't be making any close passes by our planet, at least not anytime soon. Still, there's a lot more to learn about this asteroid, but any further studies will have to wait. For now, it has disappeared behind the Sun and is out of sight. Once it reappears, astronomers will take a closer look and try to learn more about what it's made of. That part really matters, because this asteroid is somehow holding up while orbiting so close to the Sun's brutal heat. You see, this asteroid gets very near to the Sun. At its closest point, this asteroid is blasted with almost 6 times Earth's sunlight. At that distance, its surface could heat up to about 440 degrees Fahrenheit. What scientists don't know yet is how a rock this big can get baked over and over again without falling apart. And there are 2 more things astronomers want to check once it comes back into view: how fast it spins and how bright it looks. Now, by bright, I mean how much sunlight it reflects, because asteroids don't make their own sunlight. They're just big rocky chunks that shine by reflecting sunlight back at us. Anyway, those clues can tell scientists what Scooby is made of. One possibility is that this asteroid is loaded with dense metal, and that could explain how it survives the Sun's brutal heat. And if that turns out to be true, this asteroid could be a relic from when the solar system was just forming. Or maybe it slowly moved closer to the Sun because the gravity of Venus and Mercury gently pulled on it again and again over millions of years. Now, even though SE79 isn't a real danger to us, and there's still a lot we don't know about it, just finding it is already a big deal. It's a reminder that big asteroids can hide from us. So even in our own cosmic backyard, there are still blind spots where large objects can stay hidden until the right moment of twilight gives them away. And as our detection tech gets better, we keep finding more and more asteroids. By now, scientists have spotted over 1 million in the solar system. They come in all sizes, from monsters like Vesta that measure about 329 miles wide, all the way down to rocks that are smaller than a house. Now, out of all the asteroids we know, about 40,000 are what we call near-Earth asteroids, or NEAs. That just means their orbits bring them close to our neighborhood. Technically, their closest point to the Sun is less than 1.3 times the Earth-Sun distance. It's close enough for planetary defense systems to keep a careful eye on them. And that's exactly why we can relax. I mean, nobody has to lose sleep imagining an asteroid slamming into our planet. Every time scientists discover a new asteroid that comes anywhere near Earth, they track it and run the numbers right away. And then they map out its path years, decades, or even centuries into the future. And they don't do it by guesswork. NASA's automated systems, like Sentry, constantly scan the asteroid catalog and calculate whether any of these objects has even a small chance of hitting Earth over the next 100 years. If something looks risky, it jumps to the top of the watch list and gets followed up fast. So yeah, there are almost 2,000 near-Earth asteroids that technically have some chance of hitting us in the next 100 years. But don't panic. Most are small and harmless, hey, like me. And their odds of impact are usually way under 1%. See why I said we shouldn't stress too much? Cool. Now, sleep tight. Well, the space object 3I Atlas just whipped past the Sun, and instead of clearing things up, the new images made everything even stranger. Because if this thing really is a comet, then it's the strangest comet ever recorded. And if it's not a comet, then we're watching something completely new invade our solar system. So, should we be worried? This all started back in July 2025. Astronomers using the Atlas Survey telescope in Chile spotted a faint, super fast-moving object, something unlike anything they'd seen before. That was our first look at 3I Atlas, and right away, scientists had a lot of questions. Where did it come from? What's it made of? But more importantly, what is this thing? At first glance, it almost looks like a tiny cell, right? Like something you'd see under a microscope, with a bright center like a nucleus, and this fuzzy outer layer. But when we look at it from a different angle, the mystery clears up. That glow is actually a comet tail. It's precisely because it looks like and behaves like a comet that NASA finally confirmed it. Yup, 3I Atlas really is a comet. The big giveaway is that it has an icy nucleus and a coma, which is that glowing cloud of gas and dust surrounding it. But this comet is a very special one because it didn't come from our own solar system. It came from somewhere else in the Milky Way, and that's ridiculously rare. To give you an idea, we've only ever seen 3 objects like this, period. The first 2 interstellar visits were the famous Oumuamua and the comet Borisov. And now, 3I Atlas. Cool. But you might be asking, how do we know it actually came from outside our solar system? You see, normal comets are bound to the Sun. They swing around it in these big looping orbits. But 3I Atlas isn't doing that. Its crazy speed and path show it's not on a closed orbit around the Sun. And the only logical explanation is that it came from another star system and, just wandered into ours by chance. In other words, this is just a visitor passing through our solar system, and is doing it at a ridiculous speed. When we first spotted it, it was going around 137,000 miles per hour. So this object probably spent millions of years cruising through deep space just to hang around our solar system for a few months. And after this quick visit, it'll vanish into interstellar space, and we'll never see it again. Recently, 2 European Space Agency satellites, along with several NASA spacecraft near Mars, captured new images of 3I Atlas zooming in as it passed the red planet. And one of those images is pretty incredible, showing a cloud of hydrogen atoms around the comet. Scientists were pretty excited about that, as every bit of information we get from this visitor matters. Because the reality is, there are still a lot of unanswered questions about this object, starting with its size. We can't pin it down exactly yet, but NASA says it could be anywhere from about 1,400 feet to around 3.5 miles in diameter. Its exact shape is another mystery, because our telescopes can't really get a clear look at it. The nucleus is buried inside this bright coma of gas and dust, and the sunlight reflecting off all that dust basically blinds us. So for now, we're trying to see it through a bright, dusty fog. If you put all the pieces together, its behavior, its chemistry, and the images we've gotten so far, everything points to 3I Atlas being a comet. But even with all that, there are still some pretty controversial ideas floating around about what it might be. Not long after it was discovered, Harvard astrophysicist Avi Loeb said there's maybe a 30 to 40% chance this object isn't something naturally formed. That comment kicked off a wave of online buzz, with people jumping to wild possibilities. Like maybe it's some kind of extraterrestrial tech, or worse, a threat to Earth. Ooh. According to this theory, 3I Atlas might be a massive extraterrestrial mothership. Its odd trajectory could mean it's sending out little satellites toward Jupiter to collect intel for some extraterrestrial civilization. So, in that version of the story, this isn't just a comet. It's basically advanced space spy tech. But then the obvious question is, why spy on Jupiter, right? I mean, wouldn't Earth be way more interesting to an interstellar civilization? Well, in this theory, Jupiter is the target because it's so much bigger than Earth and the other neighboring planets. The idea that a planet that massive could act kind of as an interstellar beacon, something that stands out from far away. The region near Jupiter is another big reason. It's almost like it's an ideal parking spot, where space technology could basically hang out without using much fuel at all. In other words, if you were going to place advanced satellites somewhere to watch a planet, well, that's prime real estate. Pretty cool, huh? But as fun as that theory is, we gotta come back down to Earth for a second. According to the major space agencies, this thing is a comet, case closed. But that label doesn't make it any less special. 3I Atlas is still a total weirdo in the best way, and it stands out for a bunch of reasons. Let's look at 3 of the most important ones. First, this object is old, like really old. Older than me. Scientists think it's been traveling through space for at least 7 billion years. That's so far back in time that it was formed before our Sun and Earth even existed. So yeah, it's probably the most ancient thing we've ever seen in our cosmic neighborhood. Second, its glow. Comets can sometimes look kinda green, and here's why. When a comet gets closer to the Sun, the ice inside it heats up and starts releasing gas. I know the feeling. Some of that gas is made of carbon-based molecules, especially one called diatomic carbon, or C2. When sunlight hits those molecules, they light up, and to us, that glow shows up as green. But with 3I Atlas, that green color is, well, confusing. The data suggests that this comet is actually low on those carbon chain molecules. So, the big mystery is, if it doesn't have much C2, how is it glowing green at all? Well, nobody knows. And now, the third thing that makes this comet stand out. It seems to be giving off a metal alloy we've basically never seen in nature. So this comet is releasing a plume that contains nickel. That's normal. What's strange is what's missing: iron. In comets, nickel and iron usually show up in pretty similar amounts. Here, we're seeing nickel, but no clear sign of iron. And that's almost unheard of. If the data holds up, it points to an alloy called nickel tetracarbonyl, something we've only ever seen before in human-made industrial processes, not out in space. No other known object has shown this kind of signature. Well, now that you're familiar with 3I Atlas, we gotta answer the biggest question of all. Is it a threat to us? Good news! No, the comet isn't dangerous, and it's going to stay really far from Earth. So we can all take a deep breath. Well, I feel better. Although it's harmless, tracking it has been super valuable for planetary defense. You see, space agencies are always watching asteroids and comets, running the numbers on their orbits, and making sure we'd get a warning if something ever did head our way. But 3I Atlas gave them something new to practice with. This is the first time tracking data from spacecraft orbiting another planet were officially submitted to and accepted by the Minor Planet Center. That's the big global database where asteroid and comet observations get collected and checked, so scientists everywhere can stay on the same page. So, in a way, 3i Atlas was like a rehearsal. Gathering data like this from a totally new setup helps researchers sharpen their methods and improve how we spot future space objects. And that means better detection, faster tracking, and more readiness, just in case the next visitor isn't quite so friendly. So get this. Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space. We're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation. And those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the eRosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. is full of hot thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum. A chunk of rock from a different star system is heading straight toward Earth at a speed 1,000 times faster than a Formula One car. And I'm not talking about some sci-fi movie plot here. Recent research shows that our sweet little Earth could be more exposed to galactic intruders than we believed. These are called interstellar objects, or ISOs for short, and there is a certain part of Earth that has higher odds of getting hit. And we'll get back to it in a minute, but first, let's see what these ISOs are all about. We've only spotted a few so far, like One-Eye Oumuamua back in 2017, Two-Eye Borisov in 2019, and this year, Three-Eye Atlas, the third confirmed interstellar visitor, passed through our solar system. Interstellar objects like Three-Eye Atlas and Oumuamua aren't gravitationally bound to the Sun or any star in our solar system. That's why they're super fast and drift freely through the galaxy until they, by chance, cross our path. But what if one of those does more than just pass by and actually hits us? Scientists ran giant computer simulations with billions of fake interstellar objects flying around, then narrowed them down to the ones that could hit Earth. It turned out that these objects wouldn't hit the planet randomly. Low-latitude zones near the equator are more likely to get smacked. Places just above or below the tropics carry the biggest risk. And before you sigh with relief because you don't live there, there's also a bit more risk for the northern hemisphere, where almost 90% of the human population resides. It's likely to happen in a pattern and not as a random lottery because ISOs are not typical orbiters like asteroids or comets tied to the Sun. They come flying in on hyperbolic trajectories. That's a fancy way of saying they're unbound, just passing through. That means their arrival direction, speed, and relative motion all matter. The simulations show many ISOs are coming roughly from the direction the Sun moves in the galaxy, or along the Milky Way's main disk, called the galactic plane. Looks like the risk of impact also changes from season to season. The fastest potential strikes lean towards spring, when Earth is moving toward the solar apex. But overall, even calmer, slower ISO impacts are slightly more likely to happen in winter, when Earth faces away from that motion. It doesn't mean you should panic. These events are extremely rare, but it changes what we imagined. Astronomical visitor from the stars is no longer just a fantasy, it's a real risk, with a map. And this isn't just theoretical. Earth already gets hit by objects from inside our solar system all the time. Space rocks, comets, asteroids, they cross our orbit. That's why scientists keep an eye on near-Earth objects. Asteroids and comets that come within 30 million miles of Earth's orbit get that title and make it to the NEO list. To track them, scientists use a whole network of telescopes on mountains, in deserts, and even in space. NASA's Pan-STARRS in Hawaii scans the sky every night like a giant radar, takes picture after picture, and compares them. If something moves slightly between the images, that's a potential asteroid. The Catalina Sky Survey in Arizona does the same thing, and it found more than half of all near-Earth asteroids we know today. There's also NEOWISE, a space telescope that can spot dark, cold asteroids that ground-based telescopes might miss. And then there's DART, NASA's first real test of asteroid deflection. In 2022, NASA actually hit an asteroid on purpose to slightly change its orbit. The asteroid wasn't dangerous, but the test worked. And that single mission proved humanity can literally change the path of a space rock if we ever need to. And if all of this wasn't cool enough, NASA is building a new superhero to protect the Earth, NEO Surveyor. It will be the first telescope ever built specifically to detect huge numbers of asteroids and comets that could be dangerous to Earth. Here's why this thing matters so much. The solar system is crowded, messy, and full of objects we can't see with normal telescopes. A lot of asteroids are dark, like charcoal dark, and they barely reflect sunlight. That means regular optical telescopes look right past them. But even the blackest asteroid starts to warm up when the sun hits it, and warm things glow in infrared. That's where NEO Surveyor flexes. Its ultra-sensitive infrared detectors don't care how dark an asteroid is. If it's heated by sunlight, the spacecraft will spot it like a space detective with thermal vision. And the best part is that NEO Surveyor will finally see the asteroids that come at us from the direction of the sun. Ground-based telescopes can't stare at the sun unless they want to go blind. So anything approaching from that direction is basically sneaking up behind Earth wearing cosmic camouflage. NEO Surveyor fixes that. It will also catch the sneaky objects that travel ahead of Earth or behind us in our orbit, the ones that are drowned out by sunlight and slip through the cracks. These are real threats, and bigger telescopes on the ground often miss them. But when they don't miss a new object, they track it for days or weeks to figure out its orbit, basically its path around the sun. They need to know if it's going to cross Earth's orbit, if it will come close, and if so, how close. If it doesn't look harmless, it will go on to the Sentry Risk Table, which is basically Earth's cosmic watch list. So, stuff hits our atmosphere all the time. Tiny meteoroids, something like cosmic crumbs, burn up and give us shooting stars. Sometimes a slightly bigger rock shows off and creates a bright fireball. It happened over northern France a couple of years ago. Astronomers spotted a small asteroid hours before it arrived, and people on the ground got a surprise fireworks show courtesy of outer space. But every now and then, a rock comes in that's not quite big enough to survive the descent, but still large enough to release a terrifying amount of energy when it breaks apart. One example of those was the Chelyabinsk meteor. On February 15, 2013, the locals were just starting their day when the sky suddenly lit up. When it blew up about 14 miles above the ground, it released the energy of 440,000 tons of TNT. Then, a space rock, only the size of a house, slammed into Earth's atmosphere at 11 miles per second. And for a moment, it looked like a sci-fi movie had come to life. The shockwave shattered windows across almost 200 square miles, damaged thousands of buildings, and injured more than 1,600 people, mostly from flying glass. And because it came from the direction of the sun, no telescope ever saw it coming. The crazy part is that it wasn't even close to the kind of destruction a bigger asteroid could do. NASA's planetary defense experts still talk about this meteor like it was both a warning shot and a wake-up call. After this episode, NASA and international partners launched the International Asteroid Warning Network and the Planetary Defense Coordination Office, the folks whose job it is to make sure Earth doesn't get surprise smacked again. NASA is planning rapid response missions to study any asteroid that looks suspicious, and they might even send a spacecraft to check out an asteroid making a super close pass in 2029. Think of it as our planet doing regular health checkups against space hazards. The odds for any person, anywhere, to be hit by an interstellar rock in their lifetime are still minuscule. But what used to seem like science fiction, rocks crossing between stars randomly hitting us, now looks like science fact, or at least science possibility. So the more we understand how asteroids respond to impacts, the better our chances of saving Earth one day. Because you can't protect humans from a dangerous asteroid if you don't know it exists. The equipment that's getting more and more advanced gives us the advantage of time, and in a cosmic emergency, time is everything.
Did you know that over the past year, around 150 asteroids whizzed closer to Earth than the Moon? But that's not the scary part. It's that some were only noticed after they flew by. And if even one of those had taken a slightly different path, whole cities would be gone. That's what keeps the scientists worried. The invisible stuff hiding where our telescopes can't see. Let's explore what that means. Astronomers keep a list of asteroids that wander into our neighborhood. If a rock's orbit comes close to Earth, it joins a special club we call Near-Earth Objects, or NEOs. That list can include anything from a harmless little space pebble that wouldn't break a window to a rock big enough to cause an earth-shattering kaboom. NEOs are leftover materials from when the planets were forming. Some of that rubble ended up tucked safely in the asteroid belt between Mars and Jupiter, but some pieces got nudged onto paths that cut across Earth's orbit. Those are the ones we care about, because they're still wandering around today, looping around the sun, and every now and then passing uncomfortably close to us. The biggest objects are the easiest to locate. They are rare and bright enough that they stand out in sky surveys. So far, none of those big ones seem to be heading our way anytime soon. However, the real anxiety comes from the middle class of asteroids. On paper, many of them sit in the potentially hazardous object category, or PHOs, but the nickname City Destroyer explains them better. These rocks aren't huge enough to wipe out the planet, but they could flatten a city and mess with the climate for a few seasons. Some are as wide as a football stadium and hit the atmosphere faster than a speeding projectile. NASA estimates there are around 25,000 near-Earth asteroids at least 460 feet wide, but we've only discovered a fraction of them. Basically, we have solid orbits for less than half of the City Destroyer crowd. The rest only exist as numbers in simulations. We know they should be out there. We just haven't seen them yet. Why are they so hard to spot? Some asteroids are nearly coal black, blending into the cosmic night. Others hang out close to the sun from our perspective, so our telescopes get overwhelmed by brightness. It's like trying to locate a mosquito while staring directly at the sunlight. Please don't do this. From Earth, these rocks are mostly lost in the sun's glare. We only catch a glimpse just after sunset or right before sunrise. And that chance only exists if the sky is perfectly clear and the asteroid happens to be in exactly the right spot. If not, it slips back into the sun's blind spot, playing hide and seek with us. We were caught by surprise quite recently. In 2013, the Chelyabinsk meteor came from the direction of the rising sun. No one saw it in time because it was coming from the wrong direction. It exploded high above the region, shattering windows across the city and sent more than 1,000 people to the hospital. The scariest part is that the meteor was only about 60 feet wide. Now imagine a city destroyer coming from that same direction. A stadium-sized rock stepping out of the sun's glare would give us very little warning, maybe a few days or a week instead of decades. And we know that the blind zone is not empty. Observations have already revealed at least one large asteroid in that region that scientists can seriously consider a planet destroyer. It's called 2022 AP7, and it's huge. This thing is more than half a mile wide, big enough that if it ever hit Earth, it would be a catastrophic day for everyone. Astronomers found it by using the super-sensitive dark energy camera during twilight, pointing the telescope at the region of the sky most surveys normally avoided. The good news is that AP7 isn't headed straight for Earth. Its orbit crosses the orbit of our planet, but the timing doesn't line up, so we won't encounter it this pass, the next one, or even for several centuries. The bad news is what that discovery hints at. If it took this much effort to notice something like this, what else are we missing? And 2022 AP7 is just one PHO. Other asteroids closer to the Sun were also spotted during those same twilight searches. New simulations say some of those hidden rocks are not random. A bunch of them seem to share an orbit with Venus. They do not orbit Venus itself. They orbit the Sun in almost the same lane, sometimes a bit ahead of the planet, sometimes a bit behind, like kids jogging on the same track but spread out along the lap. Astronomers already know about roughly 20 of those Venus co-orbitals, and their paths are anything but stable. Gravity from Venus, Earth, and other planets keep tugging on them. And over thousands of years, those pulls could stretch their paths until they start crossing Earth's orbit. Most flybys are harmless, but one unlucky pass could be the one that counts. So what can we do about this? The first step is simple in theory. Find them earlier. The goal for astronomers is to launch infrared telescopes and get them into space. While we do have amazing telescopes like JWST or the Hubble Space Telescope, they're never pointed at the sun, as the brightness of our star can damage them. That's why we need a telescope in orbit around Venus, or one that travels along with it. It would be in a much better spot to keep an eye on the asteroids that hang out there. NASA is launching the NEO Surveyor project that aims to solve the problem. It should scan the inner solar system to spot dangerous asteroids in time. Also, we're learning that we can actually move asteroids. NASA's DART mission rammed a small spacecraft into a rock, which affected its orbit slightly. Not by much, just enough to prove that it can be done. It's like turning a plane just 1 degree while it's still across the ocean. By the time it reaches you, that tiny change can make it miss by thousands of miles. Teams around the world spend their days babysitting space rocks, and yes, that's a real paying job. NASA has the Planetary Defense Coordination Office. Europe has the NEO Coordination Center. Observatories feed them nightly sky data, and computers immediately check each dot's orbit. If a rock might wander too close, it joins the risk list and gets extra attention. Each new photo updates the orbit a little more, sometimes that make the danger level rise for a moment. That is exactly what happened with 2024 YR4, when it briefly reached level 3 on the Torino scale before better measurements calmed everyone down. The scale itself runs from 0 to 10, and anything that climbs above 3 is rare enough to raise eyebrows. The whole system works that way on purpose. Notice something strange, collect more data, then decide whether to relax or stay alert. Most of the job is actually pretty dull. It's a lot of number checking, orbit fixing, and crossing out false alarms. That quiet, careful routine is what lets the world respond quickly when a rock finally appears that isn't just passing by. So how worried should we be? For those huge planet-destroying rocks, the short answer is not much. Nothing that size is on the near-term schedule. Smaller city-level threats are trickier. The odds of one hitting Earth anytime soon are still tiny, but they're not zero. Think of it as a cosmic lottery that has been running for billions of years. Every once in a very long while, the universe draws a number that makes astronomers sit up and pay attention. It's not a reason to panic. It's a reason to build better eyes in space and make sure that if a bad ticket ever comes up, we see it in time to do something about it.